very least, who knows what Gradle is? Yeah. So, for those who don't know, it's the officially sanctioned build system for Android. There are alternatives, but this is what Google sanctions anyway. And a plugin is just like an extension point for tying into the build system. I'm going to be talking about a Gradle plugin that generates code. So some of you are probably familiar with annotation processors, such as something like Butterknife, AutoValue, Dagger, stuff like that. Basically what those do, Java-C ties into it, at compile time, it sees annotations, and then you can do whatever with it. And what those ones do is generate code. And most of them just generate boilerplate code, so you don't have to write that. And that's kind of what I'm going to be showing you what I'm doing here as well. So yeah, like I said, there's a small difference though with annotation processors. Kind of a pro and kind of a con. So with Gradle plugins, you specify inputs and outputs, and if the inputs change, then it will build them. If they don't change, then it won't build them. So it can be like an optimization there, where annotation processors just run on everything currently. All right, so the example I'm going to show is using JSON files that generate Java models to help with serialization and deserialization of JSON at runtime. So one of my biggest pet peeves of my last job was working with Jackson data bind library. Basically what that does is uses all sorts of reflection magic to take JSON from the network and create Java models from them. It's kind of insane what it can do. Even like final fields, it can somehow get those and modify them and just like does all sorts of things that are crazy unexpected. And quite frankly, I was kind of tired of that, so this is kind of what I built. Jump over to code real quick first. All right, so now we're on Android Studio. Hopefully the screen is halfway more responsive. This is a file that basically I'm just defining what the model looks like. So this here will be read in as input through a Gradle plugin, and then the Gradle plugin generates this class, which is basically just a immutable model, and something that you don't want to have to write. For each field, you have one line here, one line in the constructor parameter, and one line assigning the parameter to the field. So kind of have like 3 lines when we actually define it. We only need 1. So kind of helps with boilerplate there, but it generates more than just that. So it also generates this deserializer, which means when the network brings back the response, you can shove it into this, and it will create that immutable model for you and do like null checking and make sure all the required fields are actually coming off the wire and stuff like that. And it'll generate a serializer. So when you have your model created and you want to send it up to the server, it'll write all those out. So you don't want to write this stuff by hand. This is absolute fastest code that you can write. It uses Jackson core under the hood, the streaming API for it. So super duper duper fast. That's kind of the end result. So does anybody have questions about that? Yep.
So like how do you use this then in your actual code? Because like you have to know what your data model looks like beforehand.
Yep. For the people familiar with retrofit, there's a retrofit converter that goes along with it, which makes doing that really easy. But there's some examples in the test code for this that'll do that. But yeah, that's kind of outside the scope, at least for right now. be happy to talk about that probably afterwards. Yep.
Can you open the JSON definition?
Yep.
So the plugin it knows how to serialize and deserialize these types.
Right.
No, any other types besides these primitives?
So primitives are all built in, and then it knows how to deserialize other types that it knows about, or you can register custom serializers and deserializers. So if you're like trying to deserialize a platform type like a date, you can do that as well just by registering a custom one. Anybody else? Okay. We're going to go back to slides. Okay. So there's a couple things on how to wire this up, and I'm just going to give like super high level the main things that you need. I have this project posted on GitHub, and all of the nitty-gritty details are there, and I would be happy to explain all of the nitty-gritty details, but probably not for this short talk. So, like, basically the entry point to any Gradle plugin is going to be setting up the build, and you do that in build.gradle. There's a built-in plugin for a Java Gradle plugin, and basically you can bring in the Gradle API with that compile only down there, and then you also need access to the Android plugin, because that's how we're going to tie in to generate Java classes that the Android Gradle plugin knows about. The other key thing to the Gradle plugin is registering it. So basically, when you do that, you have to specify something in this file here. So the file would be this myplugin.properties, and inside there you just give the class as a fully qualified type, and it uses reflection to instantiate that and go through the normal pipeline of that. The one important thing to note here is this my-plugin is actually important. That's what you would apply in your build.gradle, which I would look something like this: apply plugin, Java Gradle plugin. But when you're actually using the plugin that you're writing, inside that plugin implementation, you're going to have to loop through all of the Android build variants and register a Java generating task. So you just write a custom Gradle task and just register it here, and then that'll be executed by the Android Gradle plugin. And that's kind of how you tie your plugin to know about all the Java land stuff. FYI, there's also a resource generating task as well that you can use. So if you're generating something like XML resources or something like that, you can do that too. All right, so back to more high-level stuff. The example I have uses JSON files as input. It doesn't have to be JSON files. It could be Java code, it could be Kotlin code, it could be you name it. XML, who cares? And you also don't have to use Java files as output. I chose to use Java files because there's a Java library that makes generating Java code very easy. But you could generate XML, JSON, Kotlin, you name it. So these register Java generating tasks and resource generating tasks comes from the Android Gradle plugin, and that wasn't around forever, but it's around now, and it's an easy way to tie into the build system to actually generate that code. And the Java library that makes generating Java code very easy is Java Poet listed there. And a crazy thing, and when you think about it, it makes a lot of sense, but when you're first trying to create something like this, it can be quite annoying. So the same Gradle invocation, so you type /Gradle, compile my plugin, and then execute the compile for my sample app that uses said plugin, like that doesn't work. You have to compile the plugin first, and then use the plugin that was already compiled and a different invocation of Gradle to use it in like your sample app. There's a lot here. Any questions about that? All right. So, questions overall, and I'd be happy to dig more into some of the other questions that were already listed if anybody has anything more specific.
So when you use a Gradle plugin as opposed to annotation processor, these files are generated by, you might have said that before, but they're generated without having to execute a build, right?
So in my case, you have to execute a build for those to be generated. Now, there are other more sophisticated libraries like SQLite, which is built by Square, and they also have an IntelliJ plugin, which also uses the same backend, but it's just triggered by like a code edit rather than a build application. So you can, I don't have that, but you could do that as well.
So what's the difference between the Gradle plugin and just like creating a Gradle task to do this for you? Is there a difference there?
So the benefit of a plugin is you have access to all of the build variants, and you can register that task as a Java generating task for the variants. So you could have a primitive task that like ties into some hook that's not standard in the build process and do that, but using a plugin makes it so that you can tie into that standard point. Now, to your point, 99% of the work is, actually done in the task. It's just like that Gradle plugin is the official entry point to execute that task.
For your specific plugin, the JSON, the Java converter, was there a certain task that you had to actually like say follow after the file step in the normal Android task system? Do you have to do that too? Like
Start recording?
Only complete the task after this task.
So that's all handled by that variant.register Java generating task. It knows about what steps it need to happen before whatever and does it in the right order. So you don't have to have some hacky workaround, and if they change the internals of the intro plugin and your stuff breaks, this is like the clean way to do it, if you will. So if there's not any more questions, do you guys want to know more about the plugin, or like anything else I can show you related to that? Yep, so I can show you this file here. In my case, it lives in plugin, Gradle plugin, source main resources, meta INF, Gradle plugins, and this is basically standard. And then when you actually build this, it creates the jar and packages this .properties file with your jar, and then that makes it so that you can apply plugin, my plugin data.
Is that class the Java class? Can it be Kotlin?
This one, in my case, is actually a Kotlin class. So it instantiates it via reflection, but it's just like any other JVM type, so it doesn't care that it's Kotlin or Ruby or Java. As long as it can be instantiated via reflection, it's happy. So, yeah, there's a bunch of code here that basically generates that. Chuck, I can answer your question on the retrofit converter. So I suppose the test is probably way to see how it works. So just like any other retrofit service, you just have an interface with annotated methods, and then you add the converter factory, and then once you actually call the type, so this type here is something that's unknown, so that's not good. But this one here was generated from basic.json as part of this here. So you can see it's defined here. It generates this model, and then retrofit knows how to make that, use that deserializer in this case. Anything else?